All right, our last example is to find the extreme values of a piecewise function. So again, our two conditions, we have to figure out where does the derivative not exist and where is the derivative equal to 0 to see if we have any critical points. Notice this one does not have any endpoints. So we are not guaranteed either a minimum or a maximum. So let's start with where does the derivative equal 0? So first place, we have to do the derivative. And we know it's going to be a piecewise function. So the derivative of the top function is negative 4x when x is less than or equal to 1. And then the derivative of the bottom piece is 1 when x is greater than 1. Now, at x equals 1, if I plug in 1, I get negative 4. And here I've got a slope of 1. Since negative 4 and 1 are not equal, we know that the derivative does not exist at x equals 1. So we consider that a critical point as well. That's where f prime does not exist. So I'm going to make that note. F prime of x does not exist at x equals 1. We have a jump there. All right, so now we need to know where does this derivative equal 0? Well, 1 never equals 0, so that one's out of. So now let's just check. Negative 4x equals 0 at x equals 0. So now I've got two critical points, 0 and 1. I don't have any other points in here, so I could check the points using a sign chart, but at this point I've got these two values. Let's just see which one is the min and which one is the max. So if I plug in 0 and if I plug in 1, we're plugging these into the original equation. 0 is less than 1, so I have to use this top function. So 5 minus 2 times 0 squared, we get 5. And if I plug in 1, again, I have to use this top function because that's the one where 1 is defined. So 5 minus 2 is 3. So the question is, which one is bigger? 5 is bigger than 3, so we know that this one is our maximum and this one is our minimum. So just kind of as a recap, our tips here. To find your absolute max and min values on a continuous function over a closed interval. First thing you have to do is find those critical points. Find where the derivative equals 0 and find where the derivative doesn't exist. And then find the values of the function at the endpoints. So always check those endpoints. The largest values from these two steps gives you your absolute max. The smallest gives you the absolute min. The other ones are still considered maximas and minimas. Remember, you can have multiple maxes and mins in here. But to find those global or absolute maxes and mins, find all of these pieces and find the absolute biggest and the absolute smallest.